Okay, so we're going to, after taking a look at letter A and K, getting a mole ratio of 2.623, I want to show one that's a little bit of a pain in the butt. We're going to look at letter E. We're going to skip to letter E. All right. So let's start by doing our inventory here. We have our copper. We have a hydrogen. Now we have an NO3. There is an NO3 on the other side. Normally, we could keep them together and balance them as one thing, but this will become rather more. It would become more difficult on this one. So I'm just telling you straight up. We're going to separate everything. All right. So we have just one N here. We have oxygen. There's three. So there's one carbon or copper. Geez, one hydrogen, one nitrogen, three oxygen on the left side. Right side, one copper. Now, what you need to know, or make sure we know, is that this 2 right here, when we had to split this up, normally, if we wrote it out, it'd be like, oh, it's NO3 and there's 2 of them, but can't do that here. So this 2 distributes to everybody inside. Since there's one nitrogen, this 1 gets multiplied by a 2. So we would say that there are 2 nitrogen. This 2 gets distributed to the 3 for the oxygen, so we would say that there are 6 oxygen to start. Again, we have another N, another O, and then we have the H2O here, so we have H2 and the O with the 1. Okay, well, carbon, or the coppers, I don't know why I keep saying carbon, coppers are already balanced. So we're not going to obviously start there. Nitrogens, they're not balanced, so we could potentially start there, or we could potentially start the hydrogens. But I'm going to say, let's take a look at the oxygen. We have 3 on this side. Over here, we have a total of how many on the right side? We have 6, 7, and 8. Obviously, 3 does not go into 8, so that's going to be a pain in the butt. So what I'm going to say is the first thing I would have you do is start off by taking that 8 and putting it over here, saying we need to multiply this 3 by 8, and that is going to give us 24 oxygen. So whatever we multiply, remember, becomes our coefficient. And then what happens to the hydrogen and the nitrogen? They both also then get multiplied by 8. Okay. So now, what I would probably do next would be to balance the hydrogen. So if we're balancing the hydrogen, all right, we only have this 2 over here. We have how many on total on the left side? We have 8. So what times 2 is going to give me an 8? 4. So we underline that 4. It becomes the coefficient. This 4 applies now not just to the H, but to this oxygen, which is why we had it split. That gives us 4 oxygen here. So are the hydrogens now balanced? Yeah, I'm going to put a little check mark next to that guy. All right. Well, let's see. What else could we do? Let's try and get to the nitrogens balanced. Well, we have 8 nitrogens over here. Right now we have 3. Again, that's not great. So what do you think we could do? We have, I guess, an option, 2 options possibly, but one truly correct. we can't get this 2. We can't do 2 times 4 to get 8 nitrogen because we have that additional 1 there. But if we did 2 times 3 to give us 6, and then did this 1 by 2, that would give us a total of 8, which is where we need to go. So we can start here, multiply this nitrogen by a 3. That becomes the coefficient. That 3 then applies to the copper and to this oxygen. Okay. So we're still not balanced. Jeez. Well, if we have 6 nitrogen, we need how many more to get 8? We need 2 more. So if we do 1, all right, we take this 1 nitrogen and multiply it by a coefficient of 2. That will give us 2 nitrogen. And then this 6 plus 2 will give us 8. So our nitrogens will be balanced. But don't forget that this 2 distributes as well to this oxygen here. All right, so yes, our nitrogens are balanced. So then what is our next step here? Oxygens. Let's see. Are the oxygens balanced? Let's tally them up. We have 18. We have 2. Add those 2 together. That's 20. And then this 4 down here. 24 oxygen. And how many do we have on the left side? 24. Okay, so they're good. Am I done? Oxygens are balanced. The nitrogens are balanced. The hydrogens are balanced. Am I done? What do I need left? Yeah, multiply this copper by 3. And then our mole ratio for this guy we would write it out like this, like I said, on the far right hand side. A 3, 8, 3, 2, 4. In letter F, after you guys make your your inventory, okay, I'm going to tell you to balance the fluorine first, and then the Na second, and then you guys should be able to complete that. All right, so in this one, you're going to want to balance the fluorine first, sodium second, and then you should be able to complete that one. Okay, and then there's one other one that's somewhat difficult, but it's not terrible. I'm going to show you guys the way to do that one. All right, and that letter is going to be letter H. Is everybody okay right now with that? All right, so turn to letter H. I need to show you what's going on here. All right, again, start with your inventory. We have a CO3, which is a polyatomic, but there is no CO3 on the other side, so we have to split it. So we have manganese, only one of them. We have oxygen, 2. Potassium, 2. Carbon, 1. Oxygen, 3. And then this O2 by himself, so we have 2 oxygen. All right, on the right side of the equation, or the arrow, we have 1 potassium, 1 manganese, 4 oxygen, 1 carbon, and 2 oxygen. So there's a way that you can do this. Again, there's a couple ways you can do this, but I'm going to probably just show you guys the easiest and quickest way. All right. And if you start out like you would normally, you kind of would realize, like towards the very end, you'd be like, oh crap, the oxygens aren't going to balance like this, so I would have to like erase everything and then restart. But I'm going to show you how to avoid that restart on this one. Okay. So let's say I have 2 potassium on the left side. I have 1 on the right. So first thing I would do is I would multiply this potassium on the right side by 2. So that becomes the coefficient. So the potassiums are balanced. Now this 2 affects the manganese. So we have to multiply this by 2, which gives us 2 of them. And this 4 oxygen has to get multiplied by 2 as well, giving us 8 oxygen. Okay. So what next? Well, my manganese are no longer balanced, so let's go for them. I have 2 on the right side now, only 1 over here, so I'm going to multiply that by 2. The 2 becomes the coefficient. This 2, all right, affects the whole compound, so this oxygen also has to be multiplied by 2, which gives us here a total of 4. Okay, so your manganese, are they balanced? Now, yeah. So we have manganese, potassium balanced. Carbon are currently balanced, right? Okay, well, let's see. What about the only thing that's unbalanced right now is oxygen. So what we would need to take a look at here. How many oxygens do we have total on the right-hand side? We have the 8 and 2. We have 10. How many do we have in total? How many do we have in total on this side? We have 4, 7, 9. So that doesn't really quite work out. Unfortunate. So this is where normally you guys would be like, all right, well, let's erase these guys and let's start over. But this O2 is by itself. So if we can add another 1 to this, that would give us our total of 10. Right? So can I somehow get this 2 to equal 3? What would I multiply 2 by to get 3? 1.5. Now, I know that goes against what we said. Like, wait a minute, you can't do that, right? Well, if that gives us this as a 3, we have 3, 6, and then 10, which would balance over here. So what I would do would be like, okay, if I did that, right? We say that this is a 1 and this is a 1. So to get rid of this 0.5 here, how do you get rid of a half?
By turning it into a whole?
Yeah. So to turn it to a whole, how would you do that? You have to multiply it by what? You have to multiply everything then by 2. So to get rid of this 1.5, you would have to multiply it by 2, but you can't just multiply the 1 coefficient. You would have to multiply everybody. Because this would make everything balanced right here, right? Our oxygens would be balanced then, but we can't have the half. So you would need to multiply all the coefficients by 2. So 2 times 2 becomes a 4. 2 times 1 becomes a 2. 2 times 1.5 becomes a 3. 2 times 2, a 4. And 2 times 1, a 2. And this gives us a mole ratio of a 4 to 2 to 3 to 4 to 2.
4, 2, 3, 4, 2.
Yeah. You would have gotten that right because even if you wind up starting over and then kind of made these guys 4s like you would have, it would have eventually wound up working. See it? Gotcha. Thank you. Now the rest, guys, should be pretty straightforward. The only other one would be letter J. I'm just going to set up the inventory part for that. So we have Ni. There's 2 of them. So we have 2 nickel, 3 oxygen, 1 iron, 2 hydrogen, and 1 oxygen. Over here, 1 nickel. Now, OH with some barley, that's polyatomic. Can I group that together and just balance it? Well, no, because there's no OH together on the other side. So we have to split this up. Now, remember, this 2 here on the outside distributes to everything that's inside of it. So there's 1 oxygen and 1 hydrogen, so this would be like 2 times 1 and 2 times 1. So we would have 2 oxygen, 2 hydrogen, and then on the other side, the other one over here, iron is only 1, and then again 2 oxygen and 2 hydrogen. And then I would say let's balance the nickel first. If I'm trying to balance the nickel first, tell me what I need to do. Good. This dude needs to get multiplied by 2. Correct. Since that's what I multiply it by, that becomes the coefficient. But that also applies to who? This oxygen and this hydrogen. So they also has to get doubled. Which gives me 4 here and 4 here. Okay, so the nickel, they're balanced. The irons are balanced right now, so I'm going to let that chill. What about the hydrogens? Are they? No, we have how many total hydrogen? 6, right? We have the 4 here and the 2 here. That gives us 6. We only have, yep, good. So if I do 2 times 3, that will give me a 6, which is nice. Now wait a minute, let me see, because that would make this oxygen an uneven number, right? That would give me how many? That would give me 6, or that would give me 3, but I already have 3 up here. 6, so that might work. Let's take a look. So since we multiply it by 3, that's the coefficient. So this oxygen then had to get multiplied by 3. Okay. Hydrogens, currently now balanced. The irons, currently balanced. Only dude left is oxygen. How many oxygen do we have in total? Yeah, we have 6. So this 2 and this 4. This will be 6 oxygen. So those are hydrogens. And how many oxygen do we have total on this side? 6. So everybody is balanced. So we are left on this one with a 1, 1, 3, 2, 1 ratio. Do not worry about identifying the type of reactions for this, guys. Just worry about, all right, completing the balancing, and then off on the right side, when you're complete with it, you will do the write out the mole ratio. Okay, the rest should be relatively straightforward, and I believe you guys very capable of completing those. Does anyone have any questions? No? Okay, then let's get to it.